Okay, now to try to understand the solutions of this quite general partial differential equation, second order in two variables, we seek to transform it to new, as yet unknown coordinate system psi and eta. So that is, we're seeking that the original field u is going to be a function of psi and eta, where in turn psi and eta depend upon x and y. Okay, so we need to know what those derivatives are and how they transform. So du by dx is, well, the x dependence occurs twice and it's chained through psi and eta, so we need to use the multivariable chain rule that this is du by dxi times dxi dx plus du by d eta by dx. Similarly for the y derivative, du by dy. Y dependence occurs in two places, chained through psi and eta. Therefore, du by dy is u psi dxi dy plus u eta d eta dy. Now, the second derivatives are more complicated. Algebra starts to blow out a little bit. So let's have a look at the uxx derivative in detail, and okay, so treat that as du by dx, d by dx. Now du by dx we've got this formula up here for, so this is u psi x plus u eta x. And now at this stage it's useful to do the x derivative of both of these products. So d by dx of this first product is u psi x plus u psi xx, and d by dx of this product is u eta x plus u eta x. Okay, now we've still got some x derivatives of u things, so we have to transform those. So let's treat both of these terms as a u thing differentiated with respect to x. We've got a formula for that. This formula up here is really d by dx of anything is that thing d by dxi dx plus that thing d by d eta by dx. So we'll use that formula for both of these derivatives. Okay, so d by dx applied to u psi makes this u psi from here, psi from there, psi x from there, and then multiplied by this psi x is squared. Then there's this term, right? So there is u psi from here, and then d by d eta times d eta dx times this dxi dx. And then we've got plus u psi x is that second term. And then let's do this term now. This term is the same sort of thing. Differentiate du by d eta with respect to x. So differentiate of anything with respect to x is that thing, which here is u eta, d by dxi dx, and then there's times this d eta dx, plus the thing we're differentiating, differentiated again with respect to eta, times the eta x, times this d eta by dx, squared, plus u eta xx. Okay, and that's the formula for uxx that we're going to use. There's a slight simplification in that these two terms are the same, and so they add up. So this is u psi x squared plus 2u psi eta x plus u eta x squared plus these last two terms. U psi xx plus u eta xx. Okay, so then there are the other derivative terms. The detail is very similar. We can and I'll leave it to you as an exercise to derive that. I very simply tell you what the answer is for u, y. It's the same formula as this, but with y replacing all the x's. So u psi y squared plus 2u psi eta y plus u eta y squared plus u psi y plus u eta y. Okay, so now the challenge is put this into the partial differential equation. So a uxx is a times all of this. So let's write it out. A u psi x squared plus 2u psi eta x plus u eta x squared. And I'm trying to squeeze it onto one line. U psi xx plus u eta xx. I did that one all right. Don't know about the next term. B plus buxy, because that becomes what you derive there, and I'll tell you what it is, because I've got it here. U psi x psi y plus u psi eta into psi x eta y plus psi y eta x plus u eta x eta y plus, and let's ignore that line, plus u psi xy plus u eta xy. Okay, that's the B term plus the C term, which is C u y. So that's u psi y squared plus u 2u psi eta psi y eta y plus u eta y squared plus u psi y plus u eta y.